Alright guys, hope everyone's doing well. I just want to do a quick example with you. It seems like dihybrid crosses were probably the most complicated of them all, so I just want to give you a quick review of them. For this example, I'm going to do just using two traits. Tall is dominant to dwarf. So that'll be one characteristic of the plant, and we'll say the other one is purple is dominant to white. Okay, so first part, we have our traits. We know which one is dominant. We know which one is recessive for each of them. We'll say the parental, I'm just going to use T for tall and dwarf. We'll say the parental ones is a purebred tall plant, and it has white flowers, and we will say we are crossing that with a short or dwarf plant that has purebred purple flowers. All right. Now our F1 generation, if we do a dihybrid cross of these, we are going to be getting one allele from each parent for each trait. So this one only has capital T, so that'll be a capital T. This one only has lowercase t, so we will get one of each, and then we will have a capital P and a lowercase p. I'm not going to go through all the dihybrid crosses with you guys, just because I think you're pretty good on that. Now, if we were to do the F2 generation, we would be taking two of our F1 generations and mating them together. Okay? Now I know we went over this in class, and when we do this cross, we are going to get that 9 to 3 to 3 to 1 ratio, because both of them are heterozygous. Anytime they're both heterozygous, we get that 9 to 3 to 3 to 1 ratio. All right. So this is kind of like the prelude to the problem. Now to go off of that, let's say that the problem gives us that we have tall and purple, wow, my writing is amazing, right? 1,389 of them out of all the plants. Tall and white, 525. Dwarf and purple, 462, and then lastly, dwarf and white is 184. So this is what we're given in the problem. This is our initial data. Now we're going to take this and kind of relate it to that 9 to 3 to 3 to 1 ratio. So the tall and purple, this would be both of our dominant traits, that's the 9. Both of these ones, the tall and the white and the dwarf and the purple, each of these has one dominant gene and one recessive. So each of these are going to be the 3, and then the dwarf and white, lastly, is the 1. So that's our 9 to 3 to 3 to 1 ratio, and that's what it means with what we're given in the problem. All right, so let's start up our nice little chart here. I may abbreviate a little bit just to save some time and space. So our phenotypes, we're going to have tall and purple, tall and white, dwarf and purple, and dwarf and white. Okay. And we will have our nice little chart here. So there's our phenotypes. Our observed values, and that's what we were given. That was these guys here. So for our observed, 1,389. For our tall and white, 525. For our dwarf and purple, 462. And lastly, for our dwarf and white, it's 184. Now the expected is a little bit more difficult. So let me put this aside for a second, and I'll show you guys how to do the expected. We're going to start with the dominant to begin with. So we know if we have that 9 to 3 to 1 ratio, the 9 is our tall and purple plants. This is our dominant. So what we're going to do is we're going to take this ratio, 9, dominant, over our total, which is 16. How'd I get 16? 9 plus 3 plus 3 plus 1 equals 16. We're going to set up a proportion. We want to find what our expected is for our dominant. So what we're going to do is we're going to say that x is on top because we have dominant for the 9. This will be our other dominant over our total for the ratio. And what was our total number of plants that we sampled? Well, we don't have it yet. What we got to do is we got to add all of those numbers up. And when we add all of those numbers up, we should get 2,560 plants. We can come back over here, put our 2,560 in, and now what we're going to do is we are going to cross multiply. So 2,560 times 9, and we're going to divide that by 16. All right. So when you do that, we will plug that number that we get right back into our chart, and we should get 1,440 for our dominant. Secondly, let's do our 3. This is a dominant with a recessive. So instead of that 9 out of 16 like we did over there, we're going to do 3 out of 16, but everything else is going to stay the same. We're going to have our dominant recessive, that'll be our x, our total, and then still our total. Okay? So when we solve for x on this one, after you cross multiply, you should get 480. Okay? So we will once again fill that in on our chart. Nice thing about this is if we found our first 3, guess what? We found our second 3 too, because it's going to be the same number. Okay? Lastly, let's just do our last one. It's a 1. So 1 over 16 equals x over 2,560. Where x is going to equal, once we solve it, 160. Okay? I think that's the hardest part. I think everything else is pretty easy for this. So we'll just fill out the rest of our chart. O minus E, you'll get negative 51, 45, negative 18, and 24. Take the square of that. When we do negative 51 squared, you should get 2,601. When we do 45 squared, 2025. Negative 18 squared is 325. I'm sorry, 324. My fault, guys, that looks bad. 324. And then lastly, 24 squared is 576. Last step, divide that number by our expected. So you would do 2,601 divided by 1,440. We get 1.81. 4.22 for the second one by dividing 2025 by 480. 324 divided by 480, we get 0.68. And then lastly, 3.6 by dividing 576 by 160. Add all those up to get our x squared value. And I got 10.31. Now your last step is to know what your degrees of freedom are. Well, we got 1, 2, 3, 4 phenotypes. So to do your degrees of freedom, we do 4 minus 1, and we get 3. We're going to look at your lovely x squared chart. We have 3 here. We know that our x squared value is 10.31. So coming all the way over here, here's our 5% of 7.81. Well, it's going to be on this side. So unfortunately, we would reject the hypothesis. Okay. What this means, guys, is that the data they collected from the beginning, so this data does not fit the 9:3 to 3:1 ratio. In order for it to fit, you've got to look at your degrees of freedom, and it should be on this side. Okay, so that's how you do this problem, guys, kind of to the full extent of it. Hopefully this helped you out a little bit. If you guys have any questions, you can bring them to class tomorrow. But other than that, guys, have a good rest of your night. See ya.